I welcome you all for this video lecture series on operating systems. Today we are going to discuss about contiguous memory allocation. Let's have only introduction today. The remaining we'll see later problems. Just introduction we will have today. Before that, I'll introduce myself. Myself Shankar. I'm working as assistant professor in the Department of Computer Science and Engineering, RMD Engineering College, Chennai. Let's go for the lecture. The main memory must accommodate both the operating systems and the various user processes. Therefore, need to allocate main memory in the most efficient way as much as possible. In early methods of contiguous memory allocation, the memory is usually divided into two partitions, one for resident operating systems and one for the user process. For example, if we have memory such a manner, we will reserve some portion for operating system and the rest for user process and the rest for user process. In contiguous memory allocation, each process is contained in a single section of memory that is contiguous to the section containing the next process. In memory allocation scheme, one of the simplest method for allocating memory is to divide memory into several fixed partitions. Several fixed partitions in the sense, if we have a memory and we have partitions, each partitions of in same size, each partitions of same in size. For example, this partitions 2 KB in the sense all are 2 KB, all are 2 KB, right? That is the first point. One of the simplest method for allocating memory is to divide memory into several fixed size partitions. Each partition may contain exactly one process. Every partition has only one process, even though if the size is fixed. Thus, the degree of multiprogramming is bound by the number of partitions. In this multiple partitions method, when a partition is free, a process is selected from the input queue and is loaded into the free partition. When the process terminates, the partitions becomes available for another process. In variable partition scheme, the operating systems keep a table indicate which parts of memory are available and which are occupied. Initially, all memory is available for the user processes and is considered one large block of available memory, a whole. Eventually, memory contains a set of holes of various sizes. A process enter the system, they are put into an input queue. The operating system takes into account the memory requirements of each process and the amount of available memory space in determining which processes are allocated memory. When a process is allocated space, it is loaded into memory and it can then compete for CPU time. When a process terminates, it releases its memory, which the operating system may then fill with another process from the input queue. Memory is allocated to processes until finally the memory requirements of the next process cannot be satisfied. That is, no available block of memory is large enough to hold that process. Generally, the memory blocks available comprise a set of holes of various sizes scattered throughout memory. When a process arrives and needs memory, the system searches this set for a hole that is large enough for this process. If the hole is too large, it is split into two parts. When a process terminates, it releases its block of memory, which is then placed back in the set of holes. If the new hole is adjacent to other holes, these adjacent holes are merged to form one larger hole. Thank you all for watch this lecture series on contiguous memory allocation. It's just an intro why it's required and what is contiguous space. The remaining we'll see in the upcoming classes. Thank you all.